Okay, so now we go. Awesome. All right, so here we go with notes. Let me zoom in a little bit. Oh, today's the 20th. Here's what I was yesterday. So the first thing we're going to talk about are types of lines. So some of you may have noticed that I did post notes on Canvas. Those were basic notes from Monday that or Tuesday that you could download, you could copy, you could print, etc. with the assignment. I will be adding a little bit to those, just as I've gone through a couple classes. I've added a few things. So if you copied them or printed them, just make sure that you're adding the stuff that's not there, okay? So the first type of line that we see in geometry is a segment. A segment, which just represents a piece of a line, just a portion. And it looks like a line with two endpoints, let's say A and B, and we write it, or it's written as AB with a line over it. Now that line indicates that there would be endpoints on both, but we don't actually put the endpoints. And that's to differentiate between the other ones that we do. Okay, the second line is a ray. This line has one endpoint and goes on forever. And if you'll remember, we indicate going on forever with an arrow. So it'll have an endpoint, let's say at A, and an arrow, but there'll be a point B. So this means the endpoint is at A and goes in the direction of B, and we write it as AB with a line and an arrow because it goes toward B with an arrow, the arrow's over the B. The third type of line is the actual line itself. And if you remember graphing from algebra, that it wasn't just the 3 points that we graphed, it was the line that went on forever. So a line is determined by 2 points. You can have more if you remember that there are an infinite number of points on your line. And let me admit this other person, will you copy that? Okay. And it's written as the 2 points that you're using, that you're naming, with arrows on both ends, because the line goes on forever, both directions, kind of like a number line goes in both directions. Okay. So let me let you finish copying that. So if you're just joining us, we are taking notes. So please grab something to write with, a piece of paper, because we're just jumping right in. Okay. So those are the 3 types of lines that we talk about. And just so we have clarification, a point, basically that's your dot, your coordinate that you're used to, but it has a name. Okay. Every point has a name and it's a capital letter. So every point has a name. Your lines may have more than one point. You only need to, more than 2 points. You only need 2 of them to talk about their name, the name of the line. So the next point we're going to talk about is distance. Distance or length. Sometimes our book refers to it as the length of a line segment. We also call it a distance. So think about it this way. If I have a line segment, it wouldn't make sense to have the length of a ray or the length of a line because they go in forever, okay? But if I have this line segment, we're going to call it AB. Let's say we assign numbers to A and numbers to B. So a number for A, we'll say is 8, and B, we'll call it 13. If I were to ask myself, okay, what is the distance or length between 8 and 13? You may remember all we have to do is subtract them. All we have to do is subtract the 2 numbers. So length or distance, there's this different notation, is the AB with no line over it. No line indicates it's a length. So there's 4 different things that you need to be able to remember. And don't forget, now that I have most people here, I'm going to let you use your notes and your homework on your quizzes. Right now, the plan is to have quizzes on Mondays. They'll be short and they will cover 90% of it will be just the topic from the previous week. Okay, so there may be a couple questions here or there thrown in from prior weeks, but it's only so that we keep building on it. Okay. So the distance notation is the letters, okay, and the 8 to 13 is 5. The other way we can think about that is it's the absolute value of 8 minus 13. And that would also give us 5. Any questions on that? Give me a minute. Is there anybody still writing? Okay, so those of you that joined late, I do have this part of the notes posted. I am adding a little bit to the notes that were posted. And what I'll probably do is have you, require you to copy the notes prior to class. That way we have more time just to talk about the content and answer questions. Okay. So let's talk about a few postulates. Well, you're going, well, what's a postulate? You know, it's like you've probably never heard that term before. A postulate is something that we accept as fact. If we were in a classroom setting, we'd be talking a lot more about different postulates and theorems. Theorems are things that we have to prove because in geometry, we assume nothing. It has to be given to us as a fact, and then we have to be able to prove it. And we use postulates, theorems, properties, corollaries in order to prove things mathematically. Okay. But one of the postulates that we talk about is called the segment addition postulate. Segment addition postulate. And it's very much like its name. It allows us to add segments together. So let's look at what that would look like in action. Okay, so I'm going to draw a line segment, and we're going to call it AC this time. Now, somewhere on your line segment, I want you to put B, but don't put it right in the middle. Okay, put it like closer to A. So we're going to call that point B. So segment addition postulate is going to allow me to add the segment of AB, the length, to the length of BC and get the length of AC. So we would write AB plus BC is equal to AC. Now notice what they have in common. They both have a B in common, which just means they're joined together. So you're going to actually end up with the A and the C. Okay. So what that would look like, let's say I said that AB was 3 and BC is 7. So somebody unmute yourself. Tell me what the whole length of AC would be.
10.
10. Thank you. So the whole thing would be 10 because all we had to do was add 3 and 7 to get 10. So that's what that looks like. I mean, it's really easy, but of course we're not going to have some that quite that easy. They'll have variables we'll have to solve. But what happens is this is one part plus the other part equals the whole. That's what this is talking about. Segment addition. We just add one part to one part and we get the whole. Okay, so let's look at an example. What does that really look like besides the 7 and 3 equals 10? So draw another AC, segment AC. So A, B, and C. So I know that sometimes we get towards like, well, I can do this, but I need you to label your pictures. That's something that in geometry, it's not an option. You need to label your pictures. So let's say I tell you that AB is 2x. Because it's a lot easier to do it if you can see it visually. And then let's say I told you that BC is x plus 4. And the whole thing is 31. Now, let me give you a clue. Anytime they give you the whole thing, chances are you're going to be using an addition postulate. You're going to add one to the other to get the whole. Okay, so if we use the AB plus BC equals AC, we're just simply going to fill it in. So we know that AB is 2x. We know that BC is x plus 4. And we know the whole thing of AC is 31. Now it looks like the equations that we were solving from the worksheet. Okay, so combining like terms, we have 3x plus 4. And then if we subtract 4 on both sides, so we have 3x equals 27. And dividing both sides by 3, we get x equals 9. So it isn't real hard if you just keep it very simple, and one part plus the other part equals the whole. And the whole distance can actually have a variable as well. It could have been like x plus 31. Then you would still solve. So any questions to hear? If you have a question, go ahead and unmute yourself. Anybody still writing? Okay. I don't hear anything, I will move on. Okay. So the next thing we talk about is a midpoint. So what's the midpoint? Midpoint. So now we're going to draw AC again. So somebody unmute yourself and tell me where you would expect to find the midpoint. Okay, there's 19 of you. Somebody unmute yourself. Where's the midpoint?
The middle.
In the middle. Yep. So let's put a point in the middle. We'll call it B. So if B is in the middle, there's something special about the distance from A to B and the distance from B to C. Let's think about a number line for a second. If I attach 0 to B and -3 to A and 3 to C. So I think somebody got kicked out. Let's see. Let me put it back in. If I were to ask you, what is the distance from 0 to 3? Hopefully you'd tell me 3. There's 1, 2, 3. Remember, we're counting spaces, not dots. And then the distance from 0 to -3, which is always a positive distance because distance can't be negative, is also 3. So what do we notice about the distances on each side? Somebody unmute yourself and tell me, what do we notice about the distance on each side?
They're equal.
They are equal. Thank you. Okay. And I know he's not the only one that knows how to unmute himself. Okay. Although I do appreciate your participation. Thank you so much. Okay. So they are equal. If B is a midpoint, I'm going to write if B is a midpoint, then the distance from A to B will be equal to the distance from B to C. Makes two equal parts. Okay. And there's a term that we have in geometry that's called congruent. Some of you may have heard this term before. Congruent simply means equal. Okay, but congruent means more than just equal. It means equal on every aspect. We use it more so for shapes, lines, etc. If we're talking numbers, we don't usually say 3 is congruent to 3. We say 3 equals 3. But if we're talking about a square, like this square equals this square, we're talking congruent. Okay, so that may be kind of an interchangeable term at this point, but the book uses it, and so I need you to know what it is. And we have a special symbol for congruent. It's equal with a little squiggly over it. So if you see equal or equal with a squiggly over it, just know it's equal. Okay. So now what I'm going to do is we're going to look at a few problems from the textbook. And I'm going to put it up here, and then I'm going to ask for us to go over a few of the problems together. Let me turn to the right page. Just so I can, it's what we call check for understanding. Okay, so I need everybody to unmute yourself. So think about it. You can say it or, think it, but when we're looking at PQ with a line over it, is that a line, a segment, a ray, or a length? You can look at your notes.
Segment.
It's a segment. Very good. Okay, how about the PQ with one arrow over it?
Array.
Array. Awesome. How about the PQ with two arrows over it?
A line.
Awesome. And PQ with nothing over it is a what?
Congruent.
Close.
Wow.
Distance. Awesome. Okay, distance or length. See here, the book uses length, but we're really thinking about distance from one to the other. But yeah, distance or length. Perfect. Thank you. Let's jump to number 3. So we're looking at that line AB in the figure, and we want to know, is it the same if I said AB with a line or BA, would it mean the same thing? So if we turn it around and I'm looking at the picture, it would definitely be just the same segment. That's what they're looking for. Is it the same? So that would be yes. Okay. So AB can be the same as BA. We can reverse those and not change its function or value. Okay. AB, ray AB, is it the same as ray BA? Okay, well, look at what we were talking about. What is a ray? So the ray AB starts at the endpoint A and goes in the direction of B. So that's what AB looks like. But if we look at ray BA, B would have to be the endpoint going in the direction of A. So that's not the same. Rays are very directional, so they have to be very intentional with your naming, especially with the ray. That's the most important. Okay. Because what you'll see, like number 5, is line AB the same as line BA? So if we look at the lines go on forever. So it really doesn't matter if we say AB or BA. Okay. Does that make sense? Okay. Anybody that I can clarify something for? Okay. And now they're asking for number 6, is length AB the same as length BA? So that is true. Okay. So the only one that's not the same was the ray, because the ray is very directional and intentional with the direction that it goes. Okay. Jumping down to the number line problem here. It says, what is the coordinate of P? So coordinate would be a number value associated to it. So according to that picture, P has the number value of -2, and R has the number value of 0. Okay. So the point, though, remember we said every point has a name and it's a capital letter. So if we look at number 8, the capital letter that goes to number 2 is T. Okay, so that's what they're looking for. 11, name a ray opposite of SP. Okay, so if you have ray SP, that's starting at S and going in the direction of P. That's what that would look like. Okay, but if you want a ray opposite to that, we're actually going to start at the same endpoint. We're going to start at S, but this time we're going to go in the other direction of T. So it would be ray ST. Okay. So think about it as, when you're talking about opposite rays, it kind of looks like a number line. It starts at one point and then goes in the opposite direction. And the midpoint of PT, of segment PT, okay, well, we've got -2 to 2. You can either count backwards halfway, or you can say, oh, well, I know what the midpoint is. All we do is add the 2 numbers and divide by 2. You know, you may have seen that in algebra. So we'd have -2 plus 2 is 0, divided by 2 is still 0. So that's where we'd end up, is at point R. That would be our midpoint. And it is okay for a midpoint to be a half. It could have been like 1.5. It's fine. The midpoint between S and T, which isn't actually labeled there, is 1.5. Okay. Okay, so that's just to kind of give you a little bit of, to help you be comfortable with naming distances, rays, points, coordinates. Okay, so let's look at one part of your assignment, the page 16. I'm actually going to do a few example problems that'll help you with page 16. And if you have questions or it wasn't real clear, you can also come to office hours. But I may be done a couple minutes early and I'll stay a few minutes after if you would prefer to ask your questions that way. Okay, so let's say E is the midpoint. So here's an example. On page 16, you're going to see that there's a bold like instruction over the section of problems. That's not just there for convenience. That's there to give you important information. So please get in the habit of reading and understanding all the bold information. It says that E is the midpoint. They may abbreviate things like that of segment DF. Okay. So we know that a midpoint is in the middle. We said that. So I'm going to draw the picture. You do need to draw pictures in order to get full credit. Okay, so here's G, H, here's E, D, and F. Okay, so we're going to label the information that we're given, that information in bold. So E is the midpoint. So we know that E would be in the middle and that these two parts would be equal, the DE and the EF. So we have a notation in geometry to make things equal in our picture. So if we're talking about line segments, we put tick marks. Excuse me. So we're going to put a tick mark. They're going to come in pairs. So it means that this one that has one tick mark is going to be equal or congruent to the one that has tick mark over there. If they had two tick marks, then this one would have two tick marks, and so on. So line segments will get tick marks. Do we know that E is in the middle of GH? Did they say anything about GH? Okay. So if you're looking at the bold, the only thing that's mentioned is DF. So if it didn't say it, we can't do it. So we assume nothing in geometry. That's going to be our mantra for the class. It's like we assume nothing. If it doesn't say it, we can't do it. So we don't know that where E is in that whole scheme on GH. So the only thing we can label is that. So let's look at an example. So if I tell you that DE is equal to 6x plus 3 and EF is equal to 33. So the first thing you're going to do is label your picture with the information. So we know that DE is 6x plus 3, and we know that EF is 33. We need to be able to solve for x. So the information that we know about this is we know that DE is equal to EF. So that's one of the things that we'll be using to solve these equations. So we know that segment DF, hold on, actually know that segment DF is equal, but we also know that the distance from D to E is equal to the distance to E to F. Okay. And because that's true, we can use that information, we can substitute. It's going to be one of our properties that we learn about is substitution. 6x plus 3 for DE, and we can substitute 33 for EF, and it looks like this. So 6x plus 3 is equal to 33, and then we solve. And hopefully that's not hard. Okay, so subtracting 3 on both sides, so we get 6x equals 30, and dividing by 6, we get x equals 5. And then you're done. That's it. And if you really want to check your answer, we could plug that 5 mentally, in our head. 5 times 6 is 30 plus 3 is 33. So yes, they would be equal. It would be a midpoint because they're equal on both sides. Okay, the second example, because we're going to see this part in those also, is we're going to be looking at the segment GH. So we have E, and E is just somewhere, okay, but try not to put it in the middle because then your brain always thinks that it's equal. Okay, and we're given information that GE is equal to 3x, EH is equal to 2x minus 5, and GH is equal to 100. Okay. So like I said a few minutes ago, I need you to label your picture because If we think about it, a picture is worth 1,000 words. It just really makes the visual, makes it easier to come up with the equation. Okay, so labeling, we have 3x here. We have 2x minus 5. Now, in the book, in the assignment, it doesn't always give it to you in the order. So you have to be very careful, very intentional with where you're putting your information. And then the whole thing is 100. Now, hopefully you're going, wait a minute, I've seen this before, like 10 minutes ago when we were talking about segment addition, when we have this part plus this part could equal the whole. And so that's what we're going to use. And remember I said there's a clue. If you're given the whole segment, we're going to use segment addition because we know that this part plus EH is going to equal GH. So that's going to be our formula for equation. GE plus EH is equal to GH. So that's the second formula that we're going to be using. So this would be the second one. And go back up here. This is the first one. So these are the two formulas that you're going to be using for page 16 for your assignment. Okay, so let's solve. So GE was 3x, EH is 2x minus 5, and GH is 100. Now it looks like the equations that we were solving. Okay, so 5x minus 5 is equal to 100. Adding 5 to both sides, we have 5x equals 105. And dividing both sides by 5, x equals 21. Now, a few of your problems ask, is E a midpoint? Well, if E is a midpoint, we would know that this distance from G to E would have to equal the distance from E to H. So let's find out, because we have to answer that question on a few of them. We would say, yes, it is, or no, it's not. But we would substitute the 21 in for X, so 3 times 21 would be 63. Well, that's going to be more than half of 100. We can either now subtract 100 minus 63 and get 37, or we can go 2 times 21 minus 5 and still get 37. So these are not equal, therefore E is not a midpoint. So E is not a midpoint. Okay, it does not equal on each side, so E is not a midpoint. So let me stop here and just ask if there's any questions. Feel free to unmute yourself and ask, because if you have a question, chances are there's other people that have a question.
How do you figure out if it's a midpoint again?
If it's a midpoint, because
Yeah.
if it's a midpoint, then the distance between G and E would be equal to the distance between E and H. So if this was 50 and that was 50, then E would be a midpoint. But because they're different, E is not a midpoint. And all you have to do is substitute that X in the equation up here, or in the values for your variable. So 3 times 21 and then 2 times 21 minus 5. They should give you the same answer if it's a midpoint. Good question. Any others? Okay, let me see how we're doing on time. Just a second. Okay, we're about halfway. Okay. What I'll do is, after the angles that we're doing, I'm going to give you a few minutes to actually start your assignment so that I can be here to answer questions if you have them. So that'll be very important. Sometimes I'll have more time in the middle to give you a few minutes to start, like page 16, but we had a little bit later start because people were still adding. to the class. As I was telling people in the beginning, this is a little bit bigger class than usual. So, you know, thank you for your patience. I appreciate that. Okay, so shake your hand out. We're going to keep writing. But the things that we see now are very similar to what we saw, so it might not be quite so confusing. We're talking about angles. We needed 2 points to name a line or a segment or array. We need 3 letters or dots, coordinates, 3 letters to name angles. And we have a symbol for angles. It looks like that. Okay, some of you may have seen that before. Okay, so let's look at an example of this. If we have an angle, we're going to put a point here, there, and there. So we'll call this one A, that one O, and that one C. So let's look at what makes up this angle. If I look at, Post-it though. Here. Interesting. Okay. If I look at just this part, we have a ray. We have a ray that starts at point O and goes in the direction of A. So we'd have ray OA. And if we look at this part over here, we have a ray that starts at O and goes in the direction of C. So we have ray OC. And look at where they connect. They both have the point O in common right here. That's where they connect. That point that they connect is called a vertex. So if we're going to name this angle, this is angle AOC. And I need you to notice, because this is very important, if you don't do it, it's not labeled correctly. The vertex has to be in the middle. Has to be in the middle. So write the vertex is always in the middle. So inside your angle, go ahead and put the number 1. Because sometimes they assign an angle number to it. Because there's 3 different ways we could actually reference this angle. We could say that this is angle AOC. That's what we said in the first place. But if you look at it, you can also reverse that. We could call it angle COA. As long as the O is in the middle, we can call it angle COA. And then because they were nice enough to give us a number associated with that angle, we can call it angle 1. They won't always give you an angle number. Any questions on that? Okay. Let's look at your types of angles. And I know many of you have seen at least 3 of these. And probably pre-algebra, 7th, 8th grade math, maybe even earlier. The student I was tutoring 5th and 6th grade, they were already doing this. Okay. Types of angles. So the first one would be your acute angle, which we know is less than 90 degrees. We have a right angle that would be exactly equal to 90 degrees. And if you remember, or not, maybe you don't, we have a symbol for 90 degrees, and it's an L with a little box in the corner. That's also going to imply that it's perpendicular, and we're going to get to that in a little bit. Okay, so this is super important because remember how we said pictures are really important? It's going to mean that we don't have to assume anything based on the picture. We know that this is a 90-degree angle. We don't have to think about it. We don't have to be told the information. They are going to assume, no, they're going to know that we know that it's a 90-degree angle. Okay. So obtuse angle is going to be, and most of my students know that it's greater than 90 degrees, but there's also a catch to that. An obtuse angle has to be less than 180 degrees. So we're talking somewhere between 90.1 to 179.9999 degrees. That's an obtuse angle. Because the next angle, which some of you may or may not have seen before, is called a straight angle. And that's exactly equal to 180 degrees. That would be like putting two 90s together, and we would have the line on the bottom. Okay, so this is a straight angle. So anytime you're given a straight angle, we know, we don't have to assume, we know that it's 180 degrees. And that can be a little tricky because sometimes there's like, well, I don't have enough information, but they give you a straight line. So they're going to know that you know that that's 180 degrees. Okay. So I circled those in red because those are important. Those are pieces of information that they may not tell you because they know you already know it. Okay. Any questions to there? Okay. So this next part is not actually on the notes that well, not in this detail. So if you copied the notes or printed them out.
Like them 90s, bro.
What's that? Okay. If you don't have a question, make sure that your mic is muted, please. Okay. So we're going to talk about an angle bisector. Angle bisector. So we're going to draw our angle AOC again. AOC. This time we're going to put another ray right in the middle. We're going to put ray OB right in the middle. It may not actually look like it's right in the middle, but it's going to be. Okay. Because we're going to be told that ray OB, so it starts at O and goes in the direction of B, bisects angle AOC. Well, let's look at what does a bisector do? What is, the definition of bisect? Okay. So definition, bisect means two equal parts. Two equal parts. So that means that this ray is now going to divide your angle AOC into two equal parts. So I'm going to call it 1 and 2. But if they're two equal parts, then just like a midpoint, the value of angle 1 is going to be equal to the value of angle 2. So we're going to use the notation of an arc mark. Okay. Angles are arcs, so they get arc marks. So I'm going to put this up here, use arc marks to note equal. Arc marks mean equal. Okay, so what this means to us is that angle 1 is going to be equal to angle 2. Or if they don't give you numbers, because they won't always, we can say that angle AOB is equal or congruent to angle BOC. Notice that they both have OB in common, this OB and that OB. So that's actually what they have in common. That's the middle that's going to join your two angles together to give you angle AOC. Okay. Okay. So much like the segment addition postulate, we have a new postulate, and it's called angle addition postulate. Angle addition postulate. And much like it says, okay, we're going to be able to add angles together. And just like our midpoint or segment addition, we're going to take one part plus the other part and get the whole. Let's draw another angle AOC. So AOC. This time we're going to put ray OB in it, but not in the middle. Make it closer to one than the other, because I don't want it to seem like it's equal. And I'm still going to call angle 1 and angle 2. So angle addition postulate. I'll wait for people to be done writing. Okay. Angle addition postulate says that the angle of AOB, the measurement of AOB, plus the measurement of angle BOC is equal to the whole angle, the big angle, which is the measure of angle AOC, which, just like our segment addition, one part plus the other part equals the whole. We can also say that angle 1 plus angle 2 is equal to angle AOC. But this is super important. Your weekly quiz will probably
I
have,
have a question.
Sure, go for it.
How do you know which one's angle 1 and angle 2?
They'll tell you that it's, if they label it for you like this, angle 1 and angle 2, you'll only know which one's angle 1 and angle 2 if they tell you. Okay. If they don't label it, then there is no 1 and 2. Do you see how mine's labeled? So only if it's labeled can you know which one's angle 1 and angle 2. But right now we're just talking about one angle plus the other angle equals the big angle. Okay.
Okay,
Good.
thank you.
So let's draw a picture. This is very much like the one in the book that you're going to be doing. Your second part of the assignment on page 22. And let me just clarify, you don't need to check out a book from the library. A few people have emailed me and asked me if you do, but I'm going to be posting everything that you actually need. So you don't need to get a book. If you would like to follow along, then you're welcome to get one. Just let me know. And they're going to actually label these three angles as angle 1, 2, and 3. So they're going to give you information. They're going to tell you that angle 3 is equal to 5x, and angle KAL is equal to 5x plus 10. Now remember we said we need to label our picture. So let's do that. So angle 3 is 5x. And angle KAL, well, let's figure out where is KAL. It's kind of like a road map. We're going to start at K, we're going to go to A, and then we're going to go to L. So it's the angle that I've outlined in pink. It's this whole angle, the combination of angle 1 and angle 2. That's angle KAL. So we're going to label that to be 5x plus 10. Okay, so I've got this angle of 5x and this angle of 5x plus 10, and that's supposed to equal this whole angle. So what are we going to add it together to set it equal to? Anybody have an idea?
180.
Good, very good, thank you. Because it's going to equal this straight line. This straight line, as we know from our angles, is equal to 180. Okay, so that becomes our equation. So we're going to have 5x plus 5x plus 10 is equal to 180. And this was the key right there to unlock your whole problem, that it was equal to 180. So one part plus the other part equaled the whole. So combining like terms, 10x plus 10 equals 180. Subtracting 10 on both sides, 10x equals 170. And dividing by 10, x equals 17. Okay, so when you're doing your assignment, it's very important, go back to these examples. I've made examples to mirror your assignment. I do get questions sometimes like this one. This one's exactly like the first one, except different numbers. They ask me, I don't understand, but it's like if they go back to the examples, it might make things a little more clear. So it's just there to help you. Is there anybody still writing? Okay, we're almost done, I promise. Let's do one more example that's very close to the assignment as well. Above that section of your assignment, it's going to be in bold letters, okay, that AL, ray AL, is going to bisect, I think it's in different order, but angle KAT. You may say KAL, but that's because my letters are a little different. So let's look at, what does that mean to us? So if we draw our picture again, so we're going to label this S, A, T. This one's K and L. You go 1, 2, 3. A lot of times the stuff that takes more time in geometry is actually drawing the pictures and labeling, but that's what's going to help you be successful. Okay, if you think about it, we're really only getting a couple of assignments a week, and we need to take our time to do it to be successful, to where we really understand. Okay, what does it mean to bisect? This ray AL, if this ray AL bisects, we said that bisect means it cuts it into two equal parts. So what do we know about angle 1 and angle 2? So if it bisects, what somebody can tell me, what does it mean for angle 1 and angle 2? You can look back in your notes if you need to.
They're equal.
They're equal. Awesome. That angle 2 and angle 1 are going to be equal. So we're going to put the arc marks, and we're going to make a note over here that we know that angle 1 is equal to angle 2. That's going to be huge. So that's one part. And also we're going to know, we're still going to know from this picture, we haven't even been giving it any other information. We're going to know that all three of these angles are going to be equal to our straight angle. So we're going to be able to say that angle 1 plus angle 2 plus angle 3 is equal to 180. And that's the second equation that you're going to use. So there's one like the example that we just did, and then the rest of them are like this. You're either going to choose that they're equal to each other. If you have both information of angle 1 and angle 2, you're going to use this one. If you have at all angle 3, you're going to be using this one. Okay, so let's look at an example. So if angle 1 equals 5x plus 2, and angle 2 is equal to 4x plus 8. Okay, so what do we know about angle 1 and angle 2 in our box? We said that they are equal. Okay, so we could label this 5x plus 2, and this one 4x plus 8. And we know that those would be equal. So that's our equation. We would say that 5x plus 2 is equal to 4x plus 8. And then we're going to solve. So subtracting 4x on both sides, we get x plus 2 equals 8. And then if we subtract 2 on both sides, we get x equals 6. And that's done. That one's it. Okay. Now, here's a tricky one. If I tell you that angle 2 is, let's say, 2x, and angle 3 is 5x, we're going to use this equation over here, but they don't tell me what angle 1 is. But we know that angle 1 is the same as angle 2. So keep that in mind when you're doing the problem, that if they only give you one of them, you can write it twice. Okay, so that's kind of the tricky part to that. And the last thing, last thing before we look at the assignment, we're not going to do a lot with this quite yet, but I want you to have the information, the knowledge for when we do. So this is what I call dimensional references. And really, this just goes back to the theorems that we're not covering, in that, you know, 2 points make a line, 3 points make this and that. Okay, so we know that one dot is going to be a point. Okay, that's what this is all based on. And we're going to build on that. So 2 points, I'm going to be able to draw a line through it. There's In geometry, we say that there's only one line that could be drawn through 2 points. Okay, so this is going to give us a line. Okay. And then if I were to take that same line with the 2 points and add a point not on the line, like so, we're going to call that a plane. Not like an airplane, okay, but a plane. And a lot of times when you see a picture of a plane, they have like this box or parallelogram around it. But keep in mind that a plane, like a line, goes on forever, you know, in every direction. So it'd be like the ceiling of your bedroom or your kitchen. Okay. And then the next one, we're going to take those 3 points. So we have this line with 2 points, and we're going to expand that. And what I'm going to do is I'm going to make it into like a rectangular box. If you remember how to draw that, 2 rectangles, connect the corners. So I've got those 2 points. I've got a point over here. That was our plane. And then I'm going to add a point that's not on that plane, which would be way over here. So when you've expanded your line, you get a plane. When you expand your plane with another point not on your plane, you get a space. You get a space. So we go from 1 dimension to 2 dimension to 3 dimensional. Okay. And all of those go on forever as well. Okay. So the thing I want you to connect is the building on 1 point to 2 points to 3 points to 4 points. Okay. Okay. So I'm going to put up the assignment. Okay. And remember, I am putting the assignment with the answers to them so that you can check your work. So this is actually the second part of your assignment, but it seems to be the most tricky for students, so that's why I'm putting it up first, just so we have enough time for you to ask questions. Okay, so if you see that the bold information up here says that AL bisects angle KAT, so when you draw your picture, you can label that angle 1 is equal to angle 2.